Section 9.3, two dependent population means, match pairs. In the section 9.1, we work on the two independent proportions. In the section 9.2, we work on the two means, the independent samples. And these sessions will be working on two dependent samples. We call this as the match pairs. So what is the meaning of independent and the dependent samples? When we're comparing two populations, it is important to note whether the data are two independent samples or the pair samples. Look at the independent sample example. We do have the one populations, sample of the student who used a computer in their math class in 2010. And then I do have another populations, the sample of the students who use a computer in their math class in 2023. So we do have two different populations, and the sample from these two groups are independent. And the claim statement will compare the population means score differ. Let's look at the dependent sample example. We do have the sample of the people. We're gonna collect the pulse weight. After they collect the pulse weight, they will receive the medication. And then we're gonna measure their pulse weight one more time. So we call this as the pair sample because each value in one sample can be paired with the value from the same person in other sample. Okay, so we call these two populations, they do have a dependent sample. And also we're gonna call the match pairs. And they want to know whether the pulse weight of the people go down after brief medication. So each observation in one group is coupled or paired with one particular observation in other group. For example, we want to see the before and after comparison. Or we may want to see the related objects or people like the twins or siblings or spouse. Okay, look at another match pair samples. Does drinking a small amount of alcohol reduce reaction time noticeably? 16 volunteers were given a test in which they have to push a button in response to the appearance of an image on a screen. So they do have the screen in here. When they see the moon, they have to push the button, and their reaction times will be measured. After the test, the subject will consume enough alcohol to raise their blood alcohol level to 0.05%. And then they're gonna take the reaction time again. So you're gonna see this is the first set of the data before they consume the alcohol. And then the reaction time will be measured in milliseconds. So the first person, before he consumed any alcohol, his reaction time will be 102 milliseconds. And then after they consume the alcohol, they're gonna redo the test again. So this is gonna be the second time their reaction test data. So the first person, after he consumed the alcohol, his reaction time will become 103 milliseconds. So you could see that will be a little bit slower, right? And then the person two, before the alcohol, is going to be 100 milliseconds. After the alcohol, he or she react faster, okay, will be 99 milliseconds. So you could see this is called the pair sample because like both of the data before and after, they come from the same person. Okay, and then I'm gonna find out the difference. Okay, use the first set of the data minus the second set of the data. So 102 minus 103, I'm gonna get -1. 100 minus 99, I'm gonna get the 1 in here. Okay, so the third row here, that will be the difference of the data. And then I'm gonna find out the mean value of the difference for the pair sample data. Remember how to find the mean? You're gonna add it all up, divided by 16. Then you're gonna get 6.5 here. Okay, look at the notation. That's a mean x with the d here. Okay, we call mean value of the difference D. And also I find out the sample standard deviation of the difference D for the pair sample. Okay, so I have this set of the data, I have the mean, I can use either formula or calculator to find out the sample standard deviation, which is gonna be 9.93. Okay, so this is gonna be the match pair samples. Now, let's look at the step how to perform the hypothesis testing for two dependent population means. We'll be using the t-distribution again. Step 1, verify the condition. The sample data are dependent, okay, dependent, because this is the pair sample. Second, sample will be the simple random sample. And then number 3, either or both of these conditions satisfy. Either the sample size is greater than 30 or the original population is gonna be approximately normal. Step 2, state the null and alternate hypothesis. Since we do have two populations, okay, even though this is a dependent populations, we still need to write it down which one is going to be your mean 1, which one is going to be your mean 2. We want to see the before and after the comparison, right? So we're going to let one more. This is called the mean of the difference. You could let it like mean 1 minus mean 2 or mean 2 minus mean 1. And your null hypothesis, we're gonna be specific of the mean of the difference here. Okay, talking about this guy will be equal to 0, greater than or equal to, or less than or equal to. Alternate hypothesis, again, will be not equal to, less than, and greater than. So same idea with the two-tail test, left tail, and the right tail test. Okay, keep in mind for the dependent populations mean, you guys need to let these three guys. Okay, what is the mean 1? What is the mean 2? What is your mean difference? Step 3, find the test statistic. You do have the formula here. We'll be using the t-distribution. And then the x bar d here, this is called the mean value of the difference for the pair sample data. Okay, just like our example in here. Okay, find out the difference. Use your calculator, find out the mean value of the difference. And also you need the standard deviation of the difference as well. Okay, and then the mean of difference, population mean of the difference, you could look at here. That will be equal to 0. Okay, for this course, it's gonna be always equal to 0. This guy. It's better you guys can put the preference here when you're using the calculator. Okay. Step 4, compute the p-value and interpret the p-value. So we'll be using the TCDF, lower value, upper value, and then the degree of freedom, which is gonna be n-1. Same idea, less than or equal to significance level, that will be reject. Greater than, that will be fail to reject. And then at the end, draw your conclusion. If you reject the null hypothesis, then there is sufficient evidence to support the alternate hypothesis, or that's not sufficient evidence to support the alternate hypothesis. This is the instruction how to use the TI-84 calculator to perform the hypothesis testing. You guys can check your work on the test. Now, let's do it together. Research collect the data on the numbers of hospital admission resulting from motor vehicle crash, and results are given below for 5 days on the 6th of month and the 5 days on the following 13th of the same month. Use a 0.05 significance level to test the claim that when the 13th day of a month falls on the Friday, the numbers of hospital admission from the motor vehicle crash are not affected. assume the condition for the conducting hypothesis test are met. First, verify the condition. They already assume the condition for conducting a hypothesis test are met. So I would just copy this one. If they didn't mention about it, you may just follow this part. Okay, follow the condition. Okay, then let your mean 1 and then the mean 2. I will put the mean 1 will be the number of hospital admission on the 5-day 6. Mean 2, that will be the number of hospital admission on the 5-day 13 here. Okay, and keep in mind, write it down what is the mean of the difference. I will be using 1 minus 2. Okay, so 9 minus 13, I'm gonna get -4. 5 minus 11, I'm gonna get -6. Okay, so I have this data. Make sure you guys stay on this one. Okay, it's gonna be affect your null and alternate hypothesis as well. Okay, state the null and alternate hypothesis. You can see they say the number of hospital admission from motor vehicle crash are not affected. Okay, not affected, so that will be not equal to. And then null hypothesis is going to be equal. And this is going to be the two-tailed test. Compute the test statistic. So you have the formula here. So we need to figure out what is your n. N will be 1, 2, 3, 4, 5, 6. Okay, we do have a 6 data, so n equal to 6. And the mean of the difference and standard deviation of the difference, you may want to look at your calculator. Let's do it together. Okay, now I'm gonna input the difference on my L1. So -4, enter, -6, -3, 1, -2, and -8. Okay, we're gonna click on the stat, go to the test, and then we're gonna find the t-test. Enter, and then we do have the data, so choose the data. And then the mean here, talking about the mean of the difference, which is gonna be equal to 0. And my data is gonna be on L1, right? So second one for L1. Frequency only 1. Alternate hypothesis, we do have a not equal to. And then calculate. Okay, so you will have the n, that will be equal to 6. And then the mean of the difference, that will be here, -3.667. And then the standard deviation of the difference, that will be 3.14. Okay, and then plug into the formula. Okay, use your calculator. I'll show you guys how to do it. That will be -3.667 minus 0. Okay, that's nothing. And then divided by frequency. Okay, make sure you guys put the frequency here. 3.141 divided by square root of 6. And then cos frequency. Enter. You're gonna get -2.8596. Okay, I will put -2.860. Okay, you could do the rounding. Okay, find out the p-value. So we have a two-tailed test, -2.86 here. P-value will be the area of the left tail plus the area of the right tail. So p-value will be equal to lower value, upper value, and then degree of freedom, which is going to be n minus 1, which is going to be 5. And then make sure you're going to be multiplied by 2 because you do have a 2 tails. You should get 0.0354. Okay, you can double check your work. T-test, right? We just input all the information here. Calculate. So double check your test statistic, negative 2.859. Right, we're rounding, same thing. And then p-value 0.0354, 0.0354. This is good. We're going to compare with your significance level, which is going to be less than or equal to. And then reject. So state the conclusion. Be careful for the conclusion here. We reject the null hypothesis. That means the alternate hypothesis is true. So when you state the conclusion, you have to write it out. Number of the hospital admission from motor vehicle crash is affected. Okay, it's not equal to 0. It's affected. Okay. So I'm gonna state there is sufficient evidence to conclude that the number of hospital admission is affected when the 13th day of a month falls on a Friday. Okay, example 2. Suppose the 4th grade children are exposed to a reading intervention program designed to improve scores on a reading assessment. Children were given a pre-test and post-test before and after the reading intervention, and the scores are sorted in the table below. Assume that the conditions for conducting hypothesis tests are met. Use a 0.05 significance level to test the claim that for the mean difference in reading score after participating in the program. Based on your confidence interval, do you believe the reading score improved after the intervention? So we do have a 2 set of the data, and each data will come from the same person. Okay, so this is going to be the dependent sample. So first, verify the condition. We were told to assume the condition for conducting hypothesis tests are met. Okay, because they're saying that in here. Then state the null and alternate hypothesis. But before that, state the mean 1 and then the mean 2. So the mean 1, I'm gonna put the pre-test. Mean 2, that will be the post-test. And then the mean of the difference. This time I will be using the second one minus the first one. Okay, the after result minus the before one. Okay, so I'm gonna get the positive numbers in here. Okay, try. 12 minus 10, I got the 2. 14 minus 14, I'm gonna get the 0. Okay, so you should have these numbers. And I want to do mean 2 minus mean 1 because they say that do you believe the reading score improved after the intervention? Improve means the post-test result should be better than the pre-test result. So I believe the alternate hypothesis that will be greater than 0. So I have an alternate hypothesis, the mean of the difference will be greater than 0. And then the null hypothesis that will be less than or equal to 0. And that will be white-tail test. Okay, you can let it like the mean of the difference will be mean 1 minus mean 2. Then you're gonna get negative here. And your alternate hypothesis will be less than. Null hypothesis will be greater than or equal to. Then you're gonna work on the left-tail test. That is fine. Okay, you're gonna get the same answer with me. Okay, now compute the test statistic. I want you guys try to use your calculator. Figure out all this number. check your work, you're gonna get this. Okay, plug in the mean of the difference on your calculator in L1, find out the mean and the standard deviation. And you should get the test statistic 2.54. Okay, whitetail test, finding the p-value. So that will be TCDF, lower value will be 2.54, upper value 1E99. And then degree of freedom, which is going to be n minus 1. Okay, you're going to get 0.0147. Compare with your significance level. So reject the null hypothesis. So we're going to state that there is sufficient evidence to support the reading intervention program improve reading score. Okay, because we believe alternate hypothesis is true. So the intervention program improved the reading score. You can use your calculator, double check your work again. On the test, I need you guys show me all this formula, how you plug in your work, p-value, show me the TCDF, how you get on those value. Okay, that's it.